Hello, I'm Anna Mackay and this video is on composite functions. So composite meaning two things that are coming together to make up one function. So two functions together in this case. So consider this. If we have our f function here, we've got x is mapping onto x to the power of 4 and a g function where x is mapping onto 2x plus 3. So what we have written here, it looks like fog, but it means f of g of x. Means that g converts this 2x plus 3 and then converts into our f function. Once we start to get into some examples, that'll make more sense. You might be able to recognise in this final one here, there's two components. There's the 2x plus 3 component, which was the g, and the power of 4 component, which related to the f. You might like to think of it as more of a machine, that you start with the g concept, you put that into the machine, see what happens, you take that output of what you've got and put it back into the machine and do the f part of the function on it. You don't have to write that down. Here is our technical definition for it, particularly being aware of the different types of notation. I prefer this second notation because it's clear to see that the g of x is going to be put into the f function. And here it's, again, what looks like fog, it's f of g of x is how it's read. So algebraically, let's go back to that first example. If f is x to the power of 4 and g is 2x plus 3, and we're asked to calculate f of g of x, what you do is I would write f of g of x, this will be written out neatly shortly, where you see the f function. So usually f is followed by an x, but instead of x, we're going to put in the whole of the g formula, which is 2x plus 3. So essentially we're substituting in an expression, 2x plus 3, as opposed to substituting in a number. So it works exactly the same way. Where you see an x, you put in that expression. So we then have 2x plus 3 all to the power of 4. The question often arises is it the same reversed? Is g of f of x the same thing? Here's one written out a bit more nicely. As you can see, the first one we did there, that's that 2x plus 3 to the power of 4. When you're looking at the reverse then, when you have g of f of x, for the g function, where you had an x, you're going to put in the whole of f of x. So the x plus 4 goes in, and that means wherever you had an x in the g function, you now put x to the power of 4. And what we get from that is 2 times by x to the power of 4 plus 3. And so our two answers are here and here. Now, although they each have a power of 4 component, you know that if you were to factorise out the brackets on this one, you'd get a very different answer to this one. So generally, most of the time, they are not equal, just for information's sake there. Okay, practising doing this ourselves now. If we have our f function there and our g function here, let's find f of g of x. So you would start by writing it out like this, and then the next step is you write it f and you see the g, you substitute that in, so 3 minus 4x, and work that out. So in the f function where you saw an x, you substitute in that whole expression. You must use brackets and then plus 1. And you work that out. Let's see if it's written nicely for us. Yes, there it is, to get 7 take 8x. Doing the other one, I would write g of f of x, close two brackets. Then our f of x function is 2x plus 1. And then I'm now going to substitute that 2x plus 1 into the g function, which is 3 take 4x. So 3 take 4x, but instead of an x, I've got 2x plus 1. Written out neatly, that comes to be our answer there. So you can see that was the line I got up to, and then expand the brackets, collect like terms. And as you can see, they're not the same. And most of the time they're not. Another one to practice here. Now if you substitute in values, which order do you do it then? My suggestion is substitute the values in initially, because it will probably simplify things for you. Or you could work out the composite function, the two together, and then substitute the number in at the end. But you may have larger numbers to work with, well, and they'll still have x's in them. So this is what I would do. G of f of -1 is what we're after. So first of all, let's work out the f of -1. So f of -1, subbing that into our f function, 6 multiplied by -1, take 5. We have, you don't have to show every line it's setting out. We've got -11 there. So that is f of -1. We now want to substitute that back in to get g of f of -1. And g of f of -1 is -11. So we're essentially finding out g of -11. So you look up at your g formula and you see, okay, I have to square an x and then add on an x. Making sure you use brackets and working that out to give us 110. Okay, and then the second part here, f of 0. That's okay, you're taking the function of f and redoing it again. That's not a problem. First of all, let's work out f of 0. So using our f function, we have got 6 times by 0, subtract 5, and then going back to the f of x function. Perhaps I should have put in f of 0. Gets a bit confusing there. F of 0 was -5, so now we want to put -5 into the f function. And the f function is 6 multiplied by -5, subtract 5, gives us an answer of -35. So it's practicing these skills here for composite functions. Alright, so that's the end of this video. Give it a thumbs up, subscribe to the channel, and the next video in the series is sign diagrams. Thank you.